recent renovations on tunneling technology?
How can we actually improve that?
Three-dimensional.
Three-dimensional, way too long.
I see.
And they're not stiff enough. Short and standard 3D finite element analysis.
I see. Do you think the structure design of this tunnel should have some specific concern? So, Jamal, warmly welcome you to Shanghai again. So, I would like to today invite you to introduce some of your recent renovations on tunneling technology.
All right, thanks. It's good to be with you and your group. It's twice in 1 year, so it's a very good record. Yes, as you know, we have been involved in tunneling and TBM in particular for many years. I started from hard rock tunneling and went to shielded tunneling later. With single shields, the issue is actually the fact that the machine has to excavate and then stop to install segments. And it takes a lot of time. It's almost half of the entire cycle is installation of segments. So we thought, how can we actually improve that? A friend of mine, Behzad Khorshidi, who is in Canada, came up with this idea, and we worked together to actually get this concept up and running. We debugged it, and we finally filed an international patent, as well as patents in China, Korea, and a few other places. And we have been talking to companies to see if you can make it operational. The concept here is to actually go with continuous erection of the segments in a spiral, in helical system. As you will see here, we made this animation to essentially explain the process. So one of the advantages of this system is that in addition to going steadily forward and without interruptions, it applies all type of seals to seal the interior and from water pressure. Of course, in any tunneling operations, you have to make turns. And we have come up with a patent way to actually make turns, both vertical and horizontal.
Three-dimensional.
Three-dimensional, so be able to actually move the segments and go in every direction. One big question was if the length of the shield is going to be longer. The design reviews with machine manufacturers, as a matter of fact, with this system, the length of the shield is going to be slightly shorter. Another advantage is that the length of the cylindrical, cylinders, thrust cylinders, don't have to be much longer, because there are some concept in both, Germany and here in China, that they want to do the same thing with regular segments, but in fact, the length of the hydraulic cylinders are way too long.
I see.
And they're not stiff enough. But this system, the length of this, hydraulic cylinders are short and standard. So it makes it a lot easier. The machine design altogether is relatively easy to adapt to this system. One of the issues that we have been discussing is that acceptance of the owners, because this is a very new concept, and it has to go through the process of acceptance, both by the engineers and owners. We're working on it. The next step is to go with full-scale testing. So we have to actually install this in full scale and actually subject the whole thing to stresses and shield pressure and so on, and make sure that the system can survive. This design could be with or without post-tensioning. So we have already also worked on the post-tensioning system, where a strand can go around and actually be extended, so that it gives the system flexibility relative to maybe seismic loading and essentially holding it together. So altogether, it's a very potent concept. It can actually increase the rate of tunneling maybe by 20 or 30% per day, because the fact is that the machine does not operate 24 hours. It has to stop for other reasons. So we anticipate that overall, relative to utilization, it can increase the machine utilization by 20 to 30% at least. But in the mining cycle, it can improve the mining cycle by 100%, because there is no disruptions.
If the client accepted this patent in real project. So do you think the structure design of this tunnel should have some specific concern?
We have looked at it actually with the specific design here. Of course, it needs to get some modifications, right? We cannot go to very small diameter. We have tested this for 4.5 and above, it works fine.
I see.
And then one concern at the beginning was the angle of the face. And we have actually tried that. The angle is about actually 4 to 5%. So by offsetting the thrust cylinders, it can work fine.
I see.
And we have also done a full 3D finite element analysis.
I see.
Of course, it needs to be tested in full scale to make sure how it responds. One other concern was the unsymmetrical loading when some of these thrust cylinders are disactivated. We again have looked at it for the majority of projects. It works fine. If the thrust is excessively high, what can happen is that when the segment is being installed, we can temporarily stop the machine for a short period of time to actually install and go through the turn so that there is no excessive load on any particular side. So we have thought about all the potential scenarios and try to come up with a solution for it.
So you see, in some conditions like this, if this structure used for the metro project, and then sometimes we need to build cross passages.
Correct.
And how to open the...
Correct. Again, the practice that we have today is to essentially try to isolate a certain part of the tunnel and remove the segments today, normal segments, right? Universal or otherwise. This is no exception. You have to isolate the area, load it, maybe pin the segments to the ground with some sort of an underpinning or additional reinforcement. Then you could actually go ahead and break it up and take it out. Or if you know the location of your cross passages, you can put dummy segments, maybe with some sort of steel structure, and just disassemble it and remove it. So the rest of the system can be concrete. Maybe fiber reinforced concrete is better than the normal concrete. And if you want to go through cross passages, prepare for it and you can break through.
So with this patent, actually, you do not have key segment.
Yes, there is no key segment. So everything is uniform. Means that you don't have to have multiple molds. With the same set of molds, you can actually create and generate the segments for the entire ring.
That's very interesting. I hope we can see this design realized in the world.
I look forward to it. It would actually improve the efficiency of tunneling.
Okay, thank you very much.